Question number 5. Radioactive nuclei can emit alpha, beta, or gamma radiation. 5.1 is an year 1 question. This question is from radioactive decay and nuclear radiation. Which type of radiation is the most penetrating? Students must know the properties of alpha, beta, and gamma radiation. Among all three, alpha, beta, and gamma, gamma is the most penetrating radiation, whereas alpha is a weak penetrator and beta is a moderate penetrator. Alpha particles can be stopped with a thin piece of paper, whereas we need thin aluminum sheet to stop beta particles. Five point two is an A1 question is gained from the same topic, radioactive decay and nuclear radiations. Which type of radiation is the most ionizing? The student must know the properties of alpha, beta, and gamma radiation. Among these three, alpha is the most ionizing radiation. It can easily knock out the electrons from an atom, whereas beta is a moderate ionizer and gamma radiation is the weakest ionizer. Five point three is an AO1 question from the same topic, radioactive decay and nuclear radiations. Which type of radiation has the longest range in the air? Alpha particles covers a few centimeters in the air, whereas beta radiations will travel a few meters in the air. On the other hand, gamma radiations will cover the longest distance in the air. So the correct answer is gamma radiation. When the radioactive isotopes in the Earth crust decay, they release energy. The decay causing the heating of rocks in the crust. 5.4 is an AO2 question, and this question is from atomic number, atomic mass, and the isotope topic. Figure number 8 shows the decay of uranium 238 into thorium 234, and the figure number 8, the reaction is given here. The uranium changes into thorium by emitting alpha particle. Complete the table number 2 to show the number of neutrons and protons in the nuclei. Table number 2, the isotope uranium and thorium are given. The number of neutrons are given here. We need to find the number of protons. The student must know the definition. The atomic number is actually representing the number of protons. So there are 92 protons in uranium. But if you want to find the number of neutron, it's very easy. You need to subtract 238 minus 92. You will get 146 neutrons there. Similarly, you need to subtract these values to find the number of neutrons in thorium. Two 34 minus 90. and it will give me the answer here 144 neutrons are present. If we add these values, we must get these answers. 5.5 is an AO2 question, and this question is from specific heat capacity topic. Geothermal power station pump water through heated rocks. The temperature of the water increases from 20 Celsius to its boiling point of 100 degrees Celsius. Calculate the change in thermal energy when the mass of the water heated is 150 kg. The specific heat capacity of water is given 4200 joules per kilogram Celsius. Use the physics equation sheet for your answer. Let's see what is given. First of all, students need to find the change in temperature. The temperature changes from 20 to 100. The change in temperature is 100 minus 20, that is 80 degree Celsius. Mass of the water is already given 150 kilograms, whereas specific heat capacity of water is also given. The student need to find change in thermal energy. So the formula of the thermal energy is E is equal to mass into specific heat capacity of water times the change in temperature. The change in temperature is represented by delta theta. We will use all these values in our formula. So the answer is 150 times 4200 time change in temperature.